Okay guys, we're back. I had to go to third period and definitely wearing a sweater, so that was a little different. So we're now on the real world connection. Cycling. In 2004, Lance Armstrong won the Tour de France, completing the 3,391 kilometer course in about 83.6 hours. Find Lance's unit rate, which is his average speed. Write a rule to describe the distance he cycles. D for distance. Let me remind you, D is distance. Okay, sorry. As a function of the time, T, switching colors, we're going with red. Time, that's close enough. T, he cycles. Cycling at his average speed, about how long would it take Lance to cycle 185 kilometers? So our first step is to find Lance's unit rate. So you've got your distance and time. You've got 3,391 kilometers, right there, divided by 83.6 hours. And it's approximately, which is what that means, approximately 40.6 kilometers per hour. Again, this equals approximately, I didn't spell it out, but you know what I mean. And that's what this is right here. Alright, so now step 2, let's switch colors again. We're on blue this time. For step 2, let's write a function that includes the unit rate. So we're writing a function. Remember our dirt? There's our dirt. D equals RT. So we want to write a function that includes the unit rate. And we just found the unit rate right here, which is this right here. Right there. Doing our DRT, C equals RT. We've got distance equals 40.6 T. Now we're going to step 3. I'm switching colors again, because I can. Going to orange. Step 3. This orange is for you, Adam. Even though it's not the kind of orange you like. Dead orange. I bet John likes it. Hi. Anyway, use the function to find T when D equals 185. Remember, our last thing was we want to find out how long it would take him to cycle 185 kilometers. And I did it again. I don't know how I keep going to that wrong page. Anyway, so we filled in the distance right there for that D. See our D? We filled in the 185. We kept our unit rate right here. Now we're going to find out how long it would take him. I didn't mean to write that one, that little line. Or that dot. Okay. So you've got to divide 40.6 from your T. See how I've got it on both of these? Then 40.6 will cancel out on those pieces and just leave the T right there. Leaving it all by himself. And 185 divided by 40.6 is approximately, that's your approximate symbol, approximately 4.56. So traveling at his speed, it would take Lance a little over 4.5 hours to cycle 185 kilometers. Move on to the next page, shall we? Of course we are, because you have no choice. Alright, so we're doing a quick check. Yay, quick check. Let's see how well you're doing. Suppose you walk 2 miles in 35 minutes. So we've got 2 questions. I've spaced it out a little bit so we can work on it in the space. Find the average walking speed. So we're going to look for the average walking speed. Write a rule to describe the distance D you walk as a function of the time T that you walk. So looking at my notes, which I have not turned the page recently, I'm way off. Alright, looking at our notes. My note. What I'm going to do here, try to make another dot somewhere. take my 2 and divide it by 35. So I've got my miles on top, and I've got my minutes on the bottom. What I get afterward is actually not equals an approximation. So approximately 0.057 miles per minute. Check that out. Alright. Now, I don't know how I keep changing this, guys. I think I put my hand on the little tablet that time. Sorry. Alright, so now I'm going to use the function to find how far you would walk in an hour. Because usually, when you see miles, it's not miles per minute, it's miles per hour. So how, excuse me, nose switching, how would I find out the hour? Let's see. I know I'm doing that silly Sesame Street stuff. Tell me, guys, what'd you get? Good job, Corey. The answer will be multiplied by 60 minutes. Remember, 60 minutes is an hour. So we're going to take that 0.057 and multiply it by 60. And there's no room down here to write like I wanted to. So 0 times 7 is 0. Times all the rest of that stuff's going to be 0. So go ahead and skip your 6. 6 times 7 is what? Yep, 2. Carry your 4. 6 times 5 is 30, so 34. Carry 3. 6 times 0 is 0, so you bring down the 3. So what have we got? What do you see? 1, 2, 3 is our decimal places, so starting back here. Use a different color to show you this, actually. You're going to go from this end, go 1, 2, 3, and put your decimal there. So your answer is 3.4. 3.4 what? What's the question asking? How far? And what are we using to find out how far? What kind of distance measurement are we using? We're using miles. So it's 3.4 what? Miles. Very good. Go ahead and clap. Yeah, you did well. Alright, let's get over here. See all of that? This is where we are now. To change one unit of measure to another, you can use rates that equal 1. Since 60 minutes equals 1 hour, both 60 minutes over an hour, right here, and 1 hour over 60 minutes equals 1. They're the same thing, so it's like 1. Alright, you can use 60 minutes over an hour as a conversion factor. Check that out, guys, a conversion factor. What does it mean to convert? Convert means to change. So it says to change hours into minutes, and 1 hour over 60 minutes to change minutes into hours. So let's look at that again. 60 minutes over an hour changes hours to minutes. So if you're changing from one to the other, what you're changing to goes on the top. Right here it says we're changing minutes to hours. So we're changing to hours. Look what's on the top. The hours. And down here. When converting from one unit to another, as in hours to minutes or minutes to hours, you must decide which conversion factor will produce the appropriate unit. This process is called unit analysis or dimensional analysis. Now what do we do with bold letters, guys? Yep, they go in your notes. So this right here is going in your notes. Right here. Also, while you're writing that in your notes, I really think that you probably should put that last sentence right here in your notes. Absolutely. Absolutely. Because it's telling you the 60 minutes over an hour and the 1 hour over 60 minutes, what they mean, how you can change stuff. And remember I said whatever you're changing to is on the top. Whatever you're changing from is on the bottom. Right down the top here. Change to over your change from. Well, you can pause this right now to finish taking all those notes. But for me, I'm going to go ahead and move to the next page. Don't forget to pause and write your notes, those guys, okay? Alright, converting rates. What the third example of things. We've got the speed of a cheetah. Since we're going to a cheetah, I think I'm going to go back to that orange. Because cheetahs are kind of yellowy orange or whatever. Yeah, I thought it was a good connection too. Thank you. Thanks, Tyler. Both of you. Alright, so converting rates. The speed of a cheetah. A cheetah ran 300 feet in 2.92 seconds. What was the cheetah's average speed in miles per hour? You need to convert feet to miles and seconds to hours. And I just moved again, guys. I'm going to figure this out. This tablet is hard for some reason. Anyway, I think it's going to keep resting my hand on the actual thing and somehow I slide. I don't know. Anyway, back to the cheetah. Back to the cheetah. Alright, so you need to convert feet to miles and seconds to hours. So if you look right here, as I put my little arrow for you, you got 300 feet divided by 2.92 seconds. Now I'm multiplying it by your 1 mile over the 5,280 feet because he ran in feet. We want to go to miles. And we write it 5,280 feet. That equals 1 mile. That's why you want that conversion right there. Then you got 60 seconds over a minute because you're changing from your seconds to your minutes, or to your hours, sorry. And then we have 60 minutes over an hour. So we already have it. Lost my writing utensil. We already have it in feet over second. So we're going to change. We're going to our miles per hour. And I wrote on the board there, and that was not cool. Alright. So, I want you to see right here where this stuff's marked out. Feet are on the bottom, feet are on the top. They cancel out. I'm going to add a little line up there with it again. Seconds are on the bottom, seconds are on the top. You want to cancel out seconds. Miles are on the top, hours on the bottom. They stay. There's nothing the same there. But minutes on the bottom, minutes on the top, get them out. Now you've got miles on the top and hours on the bottom. When you start multiplying across here, all the way through, you end up with 70 miles per hour. Flip my page so I can get to my correct page. Alright. So I did the math in my notebook here, if you would really like to see it. Alright, so when you get 300 times 1 mile, which there's no point multiplying by 1, it's going to be the same, and I keep writing in my spot. You're going to do 300 times 60 times 60. That gives you 1 million. Watch out, guys. Big number. 1,080,000. 1,080,000 miles divided by, and then we've got 15,417.6. Yep. And when you do the division of all of that, calculator again, it gives you that approximation of 70 miles per hour. I don't know why I'm writing the little tiny thing. I scribble that out. It's right there, guys. It's right there. And I messed it up. But you see where it is. Also, this quick check here. A sloth travels 0.15 miles per hour. Convert the speed to feet per minute. Ooh. What are we going to do? Not that, evidently. we aren't changing the page, I'm going to switch to green just because I can. Alright, so sloth travels 0.15 miles per hour. So we're going to put 0.15 minutes per hour. Convert the speed to feet per minute. Now, we got miles up here, and we got hour down here. What you want to do is make sure that you have hour on the top to cancel it out, and miles on the bottom to cancel it out. Make sure I wrote that. Yeah, I did. Alright, so first, we want that mile on the bottom, right? So 1 mile equals how many feet again? Remember, it's up here, right there. So it equals 5,280 feet. Then you're going to multiply for your hour to be seconds. Or, not seconds, I'm looking up there at the cheetah. Here, we're not looking at seconds. Alright, we want to go from hours to minutes. So we want the hour on top, so we can cancel him out. That's an H. We want to have the minutes. How many minutes are an hour? 60. I'm going to switch to red. I'm going to cancel out some stuff here right quick. Alright, so we've got our miles up here. Boop. A mile down there. Boop. Then you've got the hour here. Boop. And that's an hour. I just left off the R. Boop. I didn't write what that was. Let's see. Now whatever you multiply, it's going to be feet on top. And then what's going to be on the bottom? What did I not put here? Minutes. The bottom's going to be minutes. Alright, so 0.15 times 5,280 is not on my sheet. I didn't do it. I just went ahead and put it in the calculator evidently. So let's do this now. Figure this out. Alright, so you've got 5,280, and then you're dividing by 60. Let's see. Oh, sorry, not doing dividing by 60 yet. Multiplying. Let me back up here. Multiplying by 0.15. There we go. That's what I meant to do. Go ahead and bring down my 0. You know that's not going to make anything. We'll bring one here too, because once you get to that 1, it's all across. Alright. 500. 5 times 8 is what? Can you hear you? 40? Yep, good. You only wasn't waiting for y'all to answer me. I just had to think about it. Alright. 5 times 2 is 10, plus your 4 is your 14. So we'll carry your 1. 5 times 5 is 25, plus your 1 is what? Exactly right. Now we've got our 0 placeholder here, because we're in the second spot right here, this 1. Say 1 times 0 is 0. Okay, 1 times all of that's going to be the same number, so 8, 2, and 5. When you add all that together, we've got 0, 0, 12, carry the 1, 6, 7, 8, 9, and 7. Don't forget though that you have this decimal right here. You have to go from the back 1, 2, right there. So 792. And what is that? Feet. 792 divided by 60. And in my notes, I did my calculator again. I know, bad me. What I got was 13.2 feet per minute. Good job, guys. Let's move on. Alright, a proportion is an equation that states that two ratios are equal. The two ratios are equal. See? Alright, so A over B equals C over D. For B is not equal to 0, and B is not equal to 0. By the way, while I'm reading this out, what do you do to these bold words here? That's right, you're writing down these words. You're writing down the definitions. Alright, you read this proportion as A is to B, or you read this proportion as A is to B as C is to D. For this proportion, A and D are the extremes of the proportion. So A and D are your extremes, and B and C are the means of proportion. Another way you may say, see this proportion written as A colon B equals A colon D. Alright, sounds weird, but you'll see in a minute. And I keep writing on stuff and changing the page. What in the world? I can take that off, guys. Yeah, whatever. Alright, you can use the multiplication property of equality to solve a proportion for a variable. So right here you've got an example of that. So solve t over 9 equals 5 over 6. Now it says multiply right here. Okay, y'all wonder where we are. Right here, JJ. Multiply each side by the least common multiple of 9 and 6, which is 18. So we multiplied both sides by 18, and that gave us 2t on the left and 15 on the right. Then you've got to divide right here. You're going to divide by 2 because you want to get that t by itself. Once you divide by 2, we're going to cancel out those 2 so you only have that t. T equals 7.5. You can do that in your head because you know 15 is odd but 2 is even. What I like to do is drop down a number or drop up a number. I'm going to drop down and say that 15 minus 1, as I changed the page. 15 minus 1 would be 14. So 2 would go into 14. How many times? 7. And then add the half. Because you know 2 into 16 is 8. So 2 into 14 is 7. 2 into 16 is 8. The middle one would be 7.5. It's in the middle. Halfway there. That's how you get that 7.5. Alright, so we're on the quick check here. It says solve each proportion. So I'm going to write them down here. Let me switch colors again. I like switching colors. Can you tell? Alright, let's go into the C. Alright, x over 8. I'm writing it even though it's right there. Because I like rewriting my problems. 5 over 6. Now remember what we're supposed to do? Right here, LCM, we're finding our least common multiple. How do we find our least common multiple of 8 and 6? Let's bring it down here, guys. Alright, do you remember what we used to do earlier on? We made our what? That's right, our factor tree. Alright, so what goes into 8? 2 and 4? That's right, we got 2 and 3 here. Now we got to break down that 4 because it's not as small as it can get. That gives us 2 and 2. Now we're all broken down. Once we do that, what I like to do is put a line. Oops, I pressed something. Sorry. I like to put a line right here. Now that I have that little line there, I can look and see what numbers are over here. I have 2, 2, and 2, and I have 2 and 3 on the other side. 2 and 3 over here, and 3 2s over there. The first thing you look for is to see if there are any repeated numbers on either side. Okay, I keep clicking that thing, guys. This drives me nuts. Alright. That's neat. Alright, so we have 2 on both sides. We have 3 2s over here. We have 1 2 over here. So which one's bigger? The 3. So we're not going to use the 1 2 from the other side. So what we're going to do is 2 times 2 times 2. There's 3 2s on this side. Times 3. So 2 times 2 is 4, times 2 is 8, times 3 is what? 24. Exactly right. So we're going to multiply by 24. Multiply by 24. And that equals 24. I should have written that first, huh? Yeah, Kim. I know. I should have written it first. Alright, so we got the multiplied by 24 on both sides, since that's our least common multiple. And what do we get? I'm looking at my notes. Alright, that's going to give us 3x on this page. 3x equals 20. Alright, now that we have our 3x equals 20, what do we want to do? We're going to get that 3 off that x. That's exactly right. Because we want x by itself. We always want our variables by ourselves, by themselves. So x equals 20 over 3. Alright, so now we're going to move over to this one right here. Didn't really point in the exact same direction as I was supposed to, but you get the drift. I want you to go ahead and pause right here. So I want you to work these two problems out by yourselves. I'll come back in a second and we're going to go over them, but I want you to work on them by yourselves. Go ahead and pause now. Get my pause page ready. Okay, that was really bad. Good.